So yesterday we actually did some solving where we found a missing side length, but in the work that we did yesterday, everything ended up being cosine, just because we could focus on that. Today, it may not necessarily all be cosine, so we just want to practice seeing how some of these different ones come together. So for each of these, if you see one of these problems like on WAMAP, and it actually is saying find the value, the first thing you have to do is decide whether you'd use sine, cosine, or tangent. And I know I will use sine, cosine, or tangent every time an angle is involved. So, in the case of the first one, like if I saw this problem come up on a WAMAP, I'd make a little sketch on my paper. So I'd call that 25 degrees. I'd mark that side A is 13. And then I'm trying to find side B. Now we do that so that we can see what each of those sides are called. So, going from our 25-degree angle up here, what do I call side A? The one that I know. That one is the opposite, yes. And what do I call side B? The one I'm trying to find. It is the hypotenuse, yes. So, which trig ratio then involves the opposite and the hypotenuse? Sine. And so that's what I would actually use, is I would use sine of the angle in order to solve that problem. That's how we go about it. Now, I'm not actually having us solve these, but that's really the most important step there, is getting to whether you're using sine, cosine, or tangent. All right, let's keep rolling with these. For the next one, A equals 70. So that means that's the angle that everything's going to be relative to when we name our sides. Side B, I know it's a side because remember sides are always lowercase, is 42, and we're looking to figure out what C would be. Lowercase c, remember, side C. So, what do we call each of these sides? What do we call the 42 side? That is the hypotenuse still, yes. And what do we call the C side? What do we call side C? So I'm hearing some of you say opposite, but the opposite side would be on the other side. The opposite side, literally, of the triangle. C is actually the adjacent. All right, so if this particular triangle involves the hypotenuse and the adjacent, what are we using to solve it? Sine, cosine, or tangent? Cosine is adjacent over hypotenuse. So we would end up having to use cosine. For our next one, we know that side A is 90. Side C is 23. But of course, we need to know which angle we're going from, right? Since we're trying to find A, that means it's relative to angle A here. So that's what everything's relative to. So, what do we call each of our sides? What do I call the 90? Is that opposite, adjacent, or hypotenuse from A? That is opposite, yeah. So that's going to be our opposite there. What do we call side C over here? That is the adjacent, yes. And so, which of our three trig ratios involves the opposite and the adjacent?
Tangent.
It is tangent, yes. Because tangent, you may recall, is opposite over adjacent. Now, hopefully you're getting to where you have those memorized again. But if not, remember, you got that written down in your notes. You got each of these definitions down in your notes. Go there and check there if you still don't have it memorized. All right, last one out of this. We know A is 8. We know B is 12. And we're trying to find angle C in this case. So notice in this one, everything's now relative to angle C. When that angle moves, remember the names move. So, what do I call the side 8? That is adjacent, yes. What do I call the 12? Hypotenuse. So, is this going to be sine, cosine, or tangent? Adjacent and hypotenuse is cosine. Now these problems look a little bit different. Notice for that first one, we're trying to find sine of A. So notice, first of all, we're told that we're going from angle A. Sine is what? What's the definition of sine? Yep, opposite over hypotenuse. And again, if you don't know that by heart yet, be working on it. But you could always check your notes if you need to. So, what is the opposite side length of angle A here? It's literally on the opposite side of that. So that's our opposite. So the opposite length here is 12. What is the hypotenuse length?
20.
The 20. And so when it asks here for what sine of A is, sine, remember, is defined as the opposite over the hypotenuse. So it would be 12 over 20. Which, yes, we can reduce it, so I'm going to go ahead and reduce it. I can divide top and bottom of that fraction by 4. And so that's going to give me 3/5. Now a question for you, and this is kind of one of the critical pieces here. Do I now need to do inverse sine of that number?
Yes.
Well, notice what we were originally asked for here. It asked for sine of A. Sine is opposite over hypotenuse. It's not saying what is A, it's saying what is sine of A. So the 3/5 here, that is actually your final answer. That is what sine of A is. So having seen that one, now run with that idea, do the other ones, and then we'll check in on those other answers here in a moment. And so here we can see what all of those answers ended up working out as. Now, again, when we switch angles, so like the top half here was all relative to angle A. When we switched to angle C, that switched which side was opposite and which side was adjacent. The hypotenuse, though, stayed the same. So you notice wherever hypotenuse came up, it was always the 20 there. All right. And then sine was still opposite over adjacent, for instance. I'm sorry, opposite over hypotenuse. I misspoke. And then cosine was still adjacent over hypotenuse, and tangent was still opposite over adjacent. It's just a matter of what is actually playing the role of each of those sides in that case. This is the last problem that we're going to be doing together today. Go ahead and write this down and then do it, because it's similar to some problems that we were doing yesterday. So you can look back at those as examples as well. All right, so we're trying to find A here. So just like before, we start by deciding what do we call each of our sides. And relative to the angle that we're given, the 67 degrees, the 15 is our opposite, and side A is the adjacent. So which trig function are we going to use for opposite and adjacent? Tangent. And so we are going to start by setting this up as tangent of 67 degrees equals 15 over A, the opposite over the adjacent, and now solve from there. Yesterday we talked about how we can solve these by writing it as a proportion. And so I write the tan of 67 as tan 67 over 1, and then I can cross multiply. In this case, when we cross multiply, the A ends up multiplying by the tan of 67. Now that means that I still need to work to get the A by itself. So I'm going to undo this multiplication here by dividing both sides by tangent of 67 degrees. Which means that in order to calculate A, my answer, I'm going to have to be doing 15 divided by tangent of 67 degrees. So that's what you're actually then going to punch into your calculator to get your answer. If all goes well there, you should be getting something about 6.37.